In this video, we're going to talk about how to factor trinomials when our a value is greater than 1. So we should already know how to factor when a is equal to 1, but now we're putting a number in front of that x squared, and we're going to try to factor from there, which is going to be a little more difficult than just a equals 1 examples. So we should already know how to do that. If not, go back and watch that video because we have some of the same concepts here. So a couple ways we can do this. First, we're just going to look at guessing and checking. Now, if both of these numbers are positive, that's going to make it a little easier. So we want to just kind of talk about the different steps here when it's a little bit more complex of a problem. So we've got 3x squared here. If that 3 wasn't there, when I look at that c value -4, if we're going to factor that, we start by thinking of what multiplies to -4. So we can still start with that step. And here I wrote out the positive and negative combinations as well. So there's 4 different possibilities. But in those examples, when a equals 1, we just have a 1x and a 1x. So the order of where we put those factors don't matter. Now that we've got 3x squared, the order does matter because that's going to affect what this b value looks like. So when we're factoring here, we're only using integers, so no decimals or fractions. So I know this has got to be a 3x and 1x because 3 and 1 are the only factors of 3. So we can just guess and check. So I'm going to go ahead and put -1 and 4 in that order, -1 and 4. And we're just going to think about box or FOIL to see what we get. Well, 3x times x is always going to give us 3x squared. So that, we don't have to think about that. Any combination of these that we put in here in any order, that's always going to multiply to -4. So if we think about our box or FOIL here, when we multiply the first 2 terms and the last 2 terms, those are always going to give us what we have here. It's those other 2 that we have to think about when we multiply the inside terms and the outside terms. Those are going to give us like terms, and they have to add together to get our b value here, this -x. So in this case, 3x times 4 gives me 12x. That's a pretty big number, so I'm already thinking that might not work. This is a -1x, and 12x plus -1x is not -1x. So that's such a big difference that I know if 1 and 4 are the factors, it's not going to be 1 with the 3x and a 4 here with the x. It might be flipped around. So that would probably be my next step, is to flip those around and see what we get. But I also want to take a look at the 2's here, just to kind of get an idea of what these numbers give us. So if we've got, we'll just start with -2 here and +2 in that order. Again, we're multiplying the inside term, so I get a -2x here and a 6x there. Well, that adds to 4x. So it's a little closer, but it's not quite getting to the number I need to. So I'm going to go back here to the 1 and 4. There's no real method with guess and check, right? You can kind of get an idea of what is getting you closer and closer to the right number. So we're going to try 3x minus 4 and x plus 1. So now I move the 4 over with the 3x because I know that's going to maybe give me something different, but I left it negative here. And when we check that, we get -4x here plus 3x here, and that adds together to get a -x. So this would be our factor here. Now the other method is to factor by grouping. So if you are visual, if you kind of need to write things out, and it's not easy to think about what these 2 numbers are going to be in your head, and multiply those two terms to combine and get your b value, you might want to try the factor by grouping. So we've got this diamond method here that we talked about with a equals 1. And in that example, we took the c value and put it up top, and the b value put it in the bottom. But here you see it's a times c. So we're actually taking 2 times 3 and getting 6 in the top. So now these numbers that we're looking for have to multiply to 6 and add to 7. That one's pretty easy. 1 times 6 gives us 7. But 1 and 6 aren't going to be the two factors that we get here, right? If we have 1 and 6 as these two terms here at the end of our binomials, well, when we multiply them out in box or FOIL, it's not going to multiply to 3. So this 1 and 6 actually represents, because they add together to get 7, they represent like terms that were combined to get this number. So we want to uncombine them, if you will. So we actually want to split up that 7x into a 1x and a 6x. And the order doesn't matter, right? Order with addition and multiplication don't really matter. So you can put either one in here. So this factor by grouping, well, now we've got 4 terms here, so we can have 2 groups of 2. So we're going to split it up into 2 groups of 2 here. We put parentheses around each group, and we're going to factor each one individually. So if we're just looking at this first term here, this first group, we probably noticed that 2 and 6 are both even. They both have an x, so there's actually a 2x that we can factor out front. And when we factor that out, we're going to have something left inside. The x plus 3 doesn't have a common factor, right? So again, we factor that 2x out here, and we get x plus 3, nothing to factor out here. Well, we can divide both of these terms by 1, actually, so it technically is something we can factor out. And then you notice that both of the parentheses have x plus 3 on the inside of them. Also, just to note, when you group these, don't forget to keep this plus here. A lot of people forget that, and then it ends up looking like you're multiplying these, which is something completely different. So again, we notice that inside the parentheses, we have the same binomial, which is good. That's what we need. Because our two factors now of this trinomial are going to be the outside terms, 2x plus 1, and then what we see on the inside of both of these. But we're only going to write it once. So we got 2x plus 1 on the outside, that's one factor, times x plus 3, which is on the inside. Okay, and just to kind of make sense of why we can write it like that, and this x plus 3 doesn't have a squared or anything attached to it. Well, if we were to do FOIL, we would do 2x times 3, or excuse me, 2x times x, and 2x times 3. And that's exactly what this is right here, right? 2x times x and 2x times 3. And then we're also distributing this 1 times x and 1 times 3, and that's what this is showing right here, 1 times x, 1 times 3. So we're just taking this and writing it in a much simpler way. So again, there's our factor by grouping method. We're looking for 2 binomials as our answer.